The night the world caught fire began not with a flame, but with a silent, blinding flash on the face of the sun. In the late summer of 1859, the United States was a nation on the brink of civil war, a land of steam engines and the newly strung magic wires of the telegraph. No one looking at the sky on August 28th could have imagined that the star they orbited was about to hurl a billion-ton spear of plasma directly at their door. It started with a subtle crimson glow in the northern latitudes, a beautiful curtain of light that most dismissed as a passing curiosity. But by the morning of September 1st, the sun itself seemed to break. Amateur astronomer Richard Carrington, peering through his darkened glass in England, saw two beads of white light erupt from a massive sunspot cluster, a solar flare so powerful it remains the benchmark for stellar violence to this day. 18 hours later, the blow landed. The Earth's magnetic field didn't just bend, it buckled. In the early hours of September 2nd, the darkness of night was utterly annihilated across the American continent. In the Rocky Mountains, the aurora was so bright that gold miners woke up, saddled their horses, and began their morning chores, convinced the sun had risen hours ahead of schedule. In cities like Boston and New York City, people stood on their porches reading newspapers by the light of a blood-red sky. The heavens were filled with coruscations, shifting from deep violet to a terrifying, fiery scarlet that made the atmosphere look as though it were physically burning. Beneath this celestial fire, the pride of Victorian technology, the telegraph began to scream. The surge of electricity from the atmosphere was so intense that the copper wires acting as the nation's nervous system became overloaded with celestial current. In Philadelphia and Washington, D.C., telegraph operators watched in horror as sparks leapt from their machines, setting fire to the chemically treated paper used to record messages. Some operators were thrown from their seats by electric shocks that felt like lightning bolts. Then the truly impossible happened. Finding their lines choked with interference, operators in Boston and Portland discovered they could disconnect their massive battery stacks entirely. For over 2 hours, they sent messages back and forth using nothing but the raw electricity vibrating through the air, a ghost in the machine powered by the sun itself. While the scientists scrambled to understand the great auroral mystery, the general public was gripped by a different kind of intensity. In the deep South, where auroras were unheard of, thousands fell to their knees in New Orleans and Charleston, certain that the day of judgment had arrived. The sky was no longer a familiar ceiling, but a shifting, roaring ocean of light. This was a moment where the prehistoric fear of the heavens met the dawn of the electronic age. It was a warning shot from the cosmos, showing humanity that their newfound mastery over electricity was a fragile toy compared to the power of a restless star. When the lights finally faded and the telegraphs went silent, the world was left with a haunting realization. We live in the atmosphere of a star, and the sun, for all its life-giving warmth, is a titan that can reach out and touch the earth whenever it pleases. The golden glow over the Sierra Nevada mountains was so intense that it felt physical, a heavy blanket of light that seemed to pulse with the heartbeat of the earth. As the miners in California rubbed their eyes, they weren't looking at a sunrise, they were looking at a celestial ghost. The year was still 1859, and the American West was a landscape of dust, grit, and dreams of gold. But for a few hours, the laws of nature seemed to suspend themselves. In the mining camps of the Comstock Lode, men who had spent their lives underground emerged into a world that looked like a painting by a madman. The sky wasn't just red, it was a deep, bruised purple, streaked with veins of emerald green that danced like silk ribbons in a gale. One miner in the Rockies later wrote in his journal that the light was sufficiently bright to read the finest print, and indeed, across the United States, the nocturnal world had been abolished. In New York City, the crowds gathered on Broadway, their faces illuminated by a flickering, ghostly luminescence that cast no shadows. It was a moment of profound, shared human experience, a rare instant where every person from the Atlantic to the Pacific was looking at the same terrifying wonder. But while the common man looked up in awe or prayer, the lightning men, the telegraph operators, were engaged in a desperate battle with a force they could barely name. The telegraph lines, those spindly copper threads that had only recently begun to knit the continent together, were behaving like living things. In a small station in Vermont, a telegraph operator named George Lowe watched as a blue flame skipped across his desk, smelling of ozone and scorched wood. He reached out to touch the key, and a spark jumped 3 inches to meet his finger, numbing his arm to the shoulder. The celestial current was so powerful that it was literally melting the gutta-percha insulation off the wires in some places. This wasn't just a storm of light, it was a storm of pure energy. It was the first time in human history that our technology had been directly assaulted by the sun, and the technology was losing.
Amidst the chaos, a strange sort of peace settled over the airwaves. In the Boston office, 2 operators, realizing they were witnessing a miracle, decided to conduct an experiment. They disconnected their batteries, the massive, chemical-filled jars that provided the lifeblood of the telegraph, and found that the auroral current was more stable and powerful than their own equipment. For hours, they conversed with their counterparts in Portland, Maine, using nothing but the electricity harvested from the burning sky. "We are working with the aurora alone," they tapped out, their messages flying through the atmosphere on wings of solar fire. It was a glimpse into a future where humanity might one day harness the very energy of the cosmos. But for now, it was a beautiful, dangerous anomaly. As the second night of the storm peaked, the social fabric of the young nation began to fray under the pressure of the unknown. In the South, where the aurora borealis was a myth whispered in books, the sight of the blood sky led to widespread panic. In rural Virginia, church bells rang out in the middle of the night, calling congregations to repent before the world ended. People huddled in their homes, curtains drawn, afraid that the red light was a literal fire descending from heaven. This was the true power of the Carrington Event. It stripped away the veneer of 19th century progress and returned humanity to its primal state of wonder and terror before the majesty of the universe. The scientific community was not ready for Richard Carrington. When he burst into the Royal Astronomical Society to report that he had seen the sun flicker, he was met with polite coughs and raised eyebrows. In 1859, the sun was viewed as a static golden orb, a clockwork lamp that provided heat but was otherwise disconnected from the affairs of men. Carrington's assertion that a burst of light on a star 93 million miles away could cause a fire in a telegraph office in Alabama was seen as borderline heresy. He was a man out of time, a lone observer who had caught the universe in an act of violence that no one else was equipped to measure. He spent the following months obsessively collecting data, writing to every station manager and sea captain who had witnessed the blood sky, trying to stitch together a map of a global invisible web. As Carrington gathered his evidence, the physical world was still reeling from the magnetic hangover of the storm. In the deep Atlantic, compasses on merchant ships had spun like possessed toys, leaving navigators blind in the crimson fog. For the first time, humanity realized that the Earth was not a solid, isolated rock, but a tiny marble encased in a magnetic bubble, a bubble that could be squeezed and battered by the sun's breath. The telegraph operators, once they repaired their scorched equipment, found that the very nature of their work had changed. They were no longer just technicians, they were the first sentinels of a new kind of weather, space weather. The tragedy of the story lies in Carrington himself. Despite his groundbreaking discovery, his personal life began to mirror the chaos of the storm he tracked. He was a man of immense wealth but little social standing among the elite scientists of London. His obsession with the sun led him to build a private observatory, but his findings were often overshadowed by the proper academics of the day. He lived to see the world begin to accept the link between sunspots and auroras, but he died before the true magnitude of his event was fully understood. He had looked into the eye of the tiger and told the world it was dangerous, only to be told he was imagining the teeth. Decades passed, and the Carrington Event faded into the realm of folklore, a great light show of the Victorian era. But as the 20th century dawned and the world draped itself in power lines and radio waves, the ghost of 1859 began to haunt the halls of modern science. If a storm of that magnitude hit the Earth today, the sparks wouldn't just burn a few pieces of telegraph paper. They would melt the massive transformers that power our cities, silence the satellites that guide our planes, and erase the digital clouds where we store our lives. We are now more connected than the Victorian telegraph operators ever dreamed, which means we are more vulnerable to the sun's whims than ever before. The red sky of 1859 wasn't just a beautiful mystery, it was a blueprint for a disaster that is still waiting to repeat itself. The silence that followed the great storm of 1859 was deceptive. While the fires in the telegraph offices were extinguished and the crimson curtains pulled back from the sky, the event had permanently altered the human psyche. In the United States, a country already vibrating with the tension of the coming Civil War, the great auroral mystery became a cultural touchstone. For weeks, newspapers from New York to San Francisco were filled with letters from citizens who had experienced the impossible. One account from a woman in New Orleans described how the light was so ethereal and all-encompassing that she felt she could reach out and scoop a handful of the glow into a jar. But as the witnesses aged and the memory of the red sky faded into the sepia tones of history, a new era of vulnerability was quietly being built. We moved from copper wires to fiber optics, from steam to silicon, and from local communities to a globally interconnected grid. The Carrington Event was no longer just a historical anomaly, it became a mathematical ghost haunting our blueprints. Modern physicists now look back at Richard Carrington's sketches with a sense of quiet dread. They've calculated that the coronal mass ejection he witnessed was so perfectly aimed and so intensely magnetized that it was a 1 in 500-year event. If that same spear of solar fire were to strike Earth today, the world would not wake up to a beautiful light show, it would wake up to a digital silence. Our modern power grids are essentially giant antennas designed to pick up electricity. A Carrington-level storm would induce massive geomagnetic currents that would flow into our high-voltage transformers, heating the copper coils until they melted into useless slag. Because these transformers are massive, custom-built machines that take months to manufacture, a global blackout could last not just for days, but for years. The magic wires that Carrington saw spark would, in the 21st century, become the fuses that blow out the lights of civilization. The story of the 1859 storm serves as the ultimate reminder of human fragility. We have built a world that is incredibly fast and incredibly smart, yet it remains tethered to the mood of a 4.6 billion-year-old nuclear furnace. Carrington died in 1875, largely uncelebrated for his discovery, but every time a satellite adjusts its orbit or a power grid operator checks a solar weather report, they are paying a silent tribute to the man who first saw the sun blink. We are the children of the sun, living in its backyard, forever watching the horizon for the next time the sky decides to turn red. While the average citizen in 1859 could only pray, the modern world has built its own cathedrals of survival, buried deep beneath the Earth's crust. One of the most legendary is the Cheyenne Mountain Complex in Colorado, a fortress carved into 2,000 feet of solid granite.
Originally built to withstand a nuclear blast, its true purpose has evolved in the face of the solar threat. Inside this artificial cave, 15 three-story buildings sit on 1,500 massive steel springs designed to absorb the shock of a mountain-shaking impact. But more importantly, every inch of the facility is encased in a shell of thick steel, welded airtight to create a massive Faraday cage. This isn't just to stop a bomb, it's to stop the invisible electromagnetic pulse of a solar superstorm from frying the brains of our national defense.
Deep within these tunnels, the government maintains the alternate command center for NORAD. Here, the air is filtered, and 1.5 million gallons of water are stored in underground reservoirs. While the world above might see its power grids melt and its satellites fall silent, the men and women inside the mountain would be the only ones still watching the sky. They are the descendants of the Space Weatherman of 1967, a small unit of scientists who once saved the world from nuclear war. On May 23, 1867, a massive solar flare jammed the U.S. ballistic missile radars. Thinking it was a Soviet act of war, the military scrambled its nuclear-armed fighters. It was only a last-minute report from a solar forecaster that stopped the launch, proving that the sun could almost start a war it had no interest in winning. 60 miles outside of Washington, D.C., another ghost of the Cold War waits: Mount Weather. This sprawling underground city is the nerve center for FEMA and the designated relocation site for high-ranking government officials. If a Carrington-level event were detected today, a continuity of government plan would be triggered. While the digital clouds where we store our photos and bank accounts vanished, the essential data of the nation would be hurried into these shielded vaults. These bunkers are the lifeboats of the 21st century, designed to preserve the idea of a country even if its physical infrastructure is charred by a star. Yet, for the millions of people living in the valleys below these mountains, the story is different. We live in a world of just-in-time delivery and electric pumps that bring us water. A total grid failure wouldn't just be an inconvenience, it would be a return to the 1800s without the survival skills of our ancestors. The miners of 1859 knew how to cook over a fire and navigate by the stars. We know how to navigate by a screen that would, in this scenario, be a dark mirror. The lesson of the Carrington event isn't just about the power of the sun, but about the fragility of the web we've spun around ourselves. We have built a magnificent civilization, but we have built it on a foundation of lightning, and the sun is the ultimate master of the storm. The historical legacy of Richard Carrington's Red Sky eventually transitioned into a Victorian curiosity into the foundation of modern planetary defense. In the years following his death, the scientific world slowly caught up to his vision, realizing that the Earth is not a fortress, but a passenger on a ship sailing through a constant stream of solar particles. We now know that the sun is breathing, a rhythmic expansion and contraction of magnetic energy that peaks every 11 years. We call this the solar maximum, a season where the star's surface becomes a chaotic battlefield of loops and flares, any one of which could be the next Carrington event. To prepare for this inevitable repeat of history, humanity has launched a fleet of high-tech sentinels. The Parker Solar Probe, a heat-shielded marvel of engineering, is currently touching the sun, flying through the corona to understand the very mechanisms that Carrington could only guess at from his garden in Red Hill. Alongside it, the Solar Dynamics Observatory, SDO, watches the sun in 4K resolution, capturing every flick of a solar filament in wavelengths of light invisible to the human eye. These are our early warning systems, the modern versions of the magic wires that once sparked in the hands of terrified 19th century operators. In the United States, the Space Weather Prediction Center in Boulder, Colorado, works all the clock.
If a flare of 1859 proportions were detected today, these scientists would have roughly 20 to 30 minutes to alert the world before the first wave of radiation hit our satellites, and about 15 to 48 hours before the massive plasma cloud arrived to shake the magnetic field. In those precious hours, power companies would have to load shed, essentially performing a controlled shutdown of the world's electrical grids to prevent the transformers from melting. It would be a race against time, a choice between a temporary global blackout or a permanent catastrophic collapse of the digital age.
The story that began with miners cooking breakfast by an artificial dawn in the Rockies is not yet over. We are currently living in a period of increasing solar activity, and the great auroral mystery remains a shadow looming over our high-voltage world. Richard Carrington didn't just discover a flare, he discovered our vulnerability. He showed us that for all our skyscrapers, fiber optic cables, and silicon chips, we are still subject to the ancient rhythms of our star. The next time the sky turns blood red and the ghosts begin to speak through our machines, we won't be caught by surprise. We will look up, remember the night the world caught fire in 1859, and hope that our shields are strong enough to withstand the sun's next breath. The story of 1859 remains unfinished because the sun is a clock that never stops ticking. As of March 2026, we are standing in the middle of solar cycle 25, a period that has already shattered the conservative predictions made by scientists years ago. Just this week, on March 16, 2026, the sun released a powerful M-class solar flare from a volatile region known as AR4392. A billion-ton cloud of plasma, a coronal mass ejection, is currently racing through the void toward Earth. It is expected to strike our magnetic field today, March 19th, potentially triggering a G2-level geomagnetic storm that could send the northern lights as far south as New York and the Midwest. This current activity is a chilling echo of Carrington's discovery. While the 2026 storm is expected to be moderate, it serves as a live rehearsal for a digital civilization. In January 2026, we already saw a severe S4 radiation storm that rattled satellites and forced airlines to rethink polar flight routes. We are no longer observing history. We are living in the peak of a solar maximum that is proving to be much more aggressive than anyone anticipated. The sun's magnetic field is in the middle of a total reversal, a 22-year cycle that turns our star into a chaotic engine of flares and eruptions. Every time you look at your smartphone, navigate with GPS, or flip a light switch, you are relying on a truce with the sun. The Carrington Event of 1859 showed us what happens when that truce is broken. Today, the world's most powerful computers and shielded bunkers at Cheyenne Mountain are watching every flicker of region AR4392, knowing that the difference between a beautiful aurora and a global blackout is a matter of a few degrees of trajectory. We have built a world of light, but we are still passengers on a planet wrapped in a thin magnetic blanket, orbiting a star that is capable of plunging us into darkness with a single breath. The red sky of the past was a mystery. The red sky of the future is a warning. Richard Carrington may have died in obscurity, but today his name is spoken in the halls of NASA and NOAA as a reminder that the Victorian Internet was just the first victim of a celestial giant. As the 2026 solar peak continues, the question is no longer if another great storm will come, but when. For now, the world waits, watching the monitors, hoping that our modern magic wires are strong enough to carry the fire of the sun without burning to the ground.